In the second part of today's lesson, we will be finding the axis of symmetry using a formula. And typically I'd show you how the formula came about. However, we've got a problem. We've got to be able to understand this thing called the quadratic formula to see where this formula came from. And so the book had a choice. They could either show you how to use the quadratic formula first, where that's derived from, which is completing the square, or they could go ahead and do graphing. And they chose to do graphing so that you'd understand where these solutions come from, what they represent. So in order to graph these without having to pick points, then we're going to end up having to use this little formula, which is the axis of symmetry formula. And it goes this way. And this is what I got from the textbook. It says that for a quadratic function, and this is the function y equals. Now again, sometimes they're going to end up using a different symbol for y, and the other symbol that you might end up seeing in place of y is a function symbol, which looks like this. It says f of x, and all that represents is the same thing as y. So y equals ax squared plus bx plus c. We've seen that formula before. So here's the formula for the axis of symmetry. This is what we're going to be using. So we're going to use these two variables, b and a, and they're going to go in place of this formula, which is the opposite of b over 2a. So all we're going to do is use that formula to find the axis of symmetry of these equations. So here's our a value, and here's our b value. And we're just going to plug it into that formula. X equals the opposite of b over 2a. Well, in this case, b is negative 6. So it's the opposite of negative 6 over 2a. Well, a is 3, so we're going to put in times by 3 for this one. So remember, the opposite of a negative just means a positive. 2 times 3 makes 6, so x equals 1. And there's your answer. So what this represents is that point in which the graph ends up having the same exact shape on one side of that line as the other. That's called the axis of symmetry. So just to sketch a quick graph of what this equation would look like, it'd be a parabola facing up because it's a positive 3x squared. And what we found right here, x equals 1, means that on the x-axis at positive 1 is where that vertex lies, is where that bottom minimum point is. One space over on the x-axis. So that's what we're finding there. So on this one, here we've got our a term. Now, if you don't see a number out in front of the x squared, it's just 1. So this one is negative 1 this time. B is positive 4. So we just plug it into that formula, which goes the opposite of b over 2a. So we go ahead and substitute. We've got the opposite of 4 over 2 times by negative 1. So we do some work there. Negative 4 over negative 2 makes a positive 2. So there it is, x equals 2. So again, what that represents is on the x-axis, if I sketched a coordinate plane, on the x-axis 2 spaces over, we would have this line, this axis of symmetry, in which this graph, which should actually be opening down, because it's a negative x squared, would have its line in which we could cut it along and fold that equation, that graph, right over on top of the other side, and they'd line up perfectly. Well, another example of what we're dealing with here. So again, the first number is a, x squared. The term in front of x squared is a. Number out in front of the x term is b. And so we just plug it into that formula. X equals the opposite of b over 2a. So in this case, we have a fraction. Negative 1/2 over, and then we have 2 times by 4. Well, whenever we've got a fraction and then another fraction, you can always go back to this little rule. Remember, this represents a division sign. Okay, so we've got this, negative 1/2, and then in place of this fraction bar, if you're a little confused, always go back to this symbol here. And then 2 times 4 is just 8. Well, what we've got is a division problem with fractions. So remember what to do with fractions in division? Hopefully you remember to take the reciprocal. So again, that first number stays the same. You multiply by the reciprocal. So the 8 goes on the bottom. So notice the 2 is being multiplied by the 8. And so we're left with negative 1/16. And that is the x value. That is the axis of symmetry. So a quicker way to do this is, if you forget this little rule, you always go back to this division sign, this fraction bar meaning division. But if you think about it, all we did is we took this 2 and we just kind of slid this fraction down. We just kind of brought it down. So the 1 is right, the negative 1 is right up on top of this large fraction bar, and the negative, or this 2, just got brought down here. And then we multiplied. 2 times 2 is 4, times 4 is 16. So that's a way you can remember to do it if you've got a fraction on top of the large fraction bar. Well, the next set of directions is going to ask us to do an extra step, and that's to find the vertex. And once we're able to find the vertex, this point here, either the minimum point or the maximum point, we'll be able to graph all different types of quadratics just by looking at the number out in front of x squared. So the way we're going to do this one is the same as what we were doing up here. We're going to find that first value, the x value. And then once we have it, we can substitute it into the equation to find y. So let's try it. X equals the opposite of b over 2a. So we've written that down a few times, so let's just go ahead and substitute the numbers in. So b is negative 6. So the opposite of negative 6 over 2 times by 3. Well, this looks like the same equation as the one before. Just about the same, just different y value here, or c value, that is. And so the opposite of 6 is, or opposite of negative 6 is 6. Over 2 times 3 is 6, which makes 1. All right, so now we have our x value. Now just substitute. So take this 1, and let's put it in place of these x's. So we'll put it in this x here, and we're going to slide it right here in place of this x. So let's go ahead and find out what y is. Y is 3 times by 1 squared, so we got to square 1, and then multiply by 3, minus 6 times by 1, and then minus 2. So go ahead and do some work there. So this is what y equals. Well, 1 squared is just 1, times 3 is 3, minus 6 minus 2. So we do some more work there. Makes negative 3 take away 2, makes negative 5. So there it is. We've got our point in which the graph ends up bottoming out, the low point in the graph, which is 1, comma, negative 5. There is our answer. Well, let's try the next one here. Let's say we had the a term looks like it's 3, b is positive 12. So we just go ahead and find the x value first. So we're going to substitute 12 in for the opposite of b. So negative 12 over 2 times the a value. So remember, it's the opposite of b, so that's why I switched the sign. Whatever b is, it's always the opposite of that. So negative 12 over 6 makes negative 2. So you're going to take that negative 2, and you're just going to substitute it. You're going to put it in place of these x's in the equation above. And then find out what y is. So y equals 3 times by negative 2 squared, and then plus 12 times by negative 2 minus 10. So you do some work there. Remember, exponents first. So 3 times by 4, and then plus negative 24 minus 10. And here's something you'll notice when we're trying to find this vertex. Now remember, these graphs are symmetrical. So if I was to draw one again, remember if I draw it with respect to the y-axis being the axis of symmetry. Remember, we're trying to find this axis of symmetry right here, this vertex. So what is on one side is going to be exactly the same distance from that line on the other side. So every single time, what you'll notice is that with the a term and the b term here our a term is 12, and here our a term, oops, I didn't multiply the 12 and the 2, so let me go ahead and do that real quick. Here our b term is double that value. And so notice that it's double the value, but just the opposite sign. So when we're dealing with these problems, these will always subtract, and it'll make one of the two values depending on which one's doubled. And so in this case, it's negative 12 minus 10 makes negative 22. And so that means we end up having to go over 2 spaces to the left and then down 22 spaces, negative 22, in order to get to that vertex. So that vertex was over 2 to the left, down 22 spaces for that problem. Well, let's take a look at the next one here. Here our a value is 1 because we don't see a number out in front of the x squared, so we treat it as 1. B is the 2. So we just go ahead and substitute those numbers in. X equals the opposite of b, so negative 2, over 2 times by 1. So go ahead and do some work there. Negative 2 over 2 makes negative 1. So we've got our x value. So all you have to do now is find out what y is. We're taking that negative 1, putting in for these x's here to find out what y is. Y equals negative 1 squared. Now notice you're squaring negative 1, so it's going to make a positive, plus 2 times by negative 1 minus 35. So let's see what happens. We talked about before how the first two terms, one is double the other, and you're always subtracting. So if you just look at the numbers without the signs. So this one's a positive 1. This one's a minus 2. You see how 2 is double 1. And then from there, again, we're subtracting the two numbers. 1 is always going to be negative. So it's negative 1 minus 35, which makes negative 36. So there it is. Y equals negative 36 when x is negative 1. So negative 1 comma negative 36. So what this helps us do is it helps us graph the equation quickly. Once we have this point, we can plot that point, and there's a general way to graph equations that we'll talk about later on. Well, on problem number 18 that you'll see, it's a problem similar to this, where it's asking a question with regards to whether an object can reach a certain height. And so remember, what you're trying to find here is either going to be a maximum or minimum value when you're trying to find this vertex. In this case, our vertex is going to be a maximum value because of this sign right here. Because it's a negative 16, that means we're going to end up having a maximum value. And that's what we want to find, is we want to find out what that maximum value is. And again, it's because of the negative sign in front of the 16. So we're going to end up, it says that a superhero leaps over a tall building. The function is formed by this. Gives the superhero's height in feet as a function of time. So here's what it looks like. So here is height in feet, and here is time. And they don't specify the units of time, but we'll go ahead and just write time. And what happens is the superhero jumps and then eventually hits a certain maximum height and comes back down. And my graph doesn't look symmetrical, but it should be. I just can't draw that as well as I could with a regular pencil here. But anyhow, that's what it'll look like. And so what we're trying to find is, will that superhero end up getting up to the top of the building? Because the building is here, let's say. Let's say he does. I don't know if we'll find out if he does once we solve the problem, but let's say he does. That means that if this is 612 feet, that means his maximum height would be higher than 612 feet. And so that's what we're trying to find is the maximum height higher or is it lower? So if it was lower, let's try to draw another scenario here. Let's say he doesn't make it. Then it would look like this. He'd come up and he'd hit the building and end up coming back down. But let's say the building wasn't even there. So let's say the equation would look like this. This way, it would show that if we find the maximum height is lower than this number, then he would not clear the building. So that's what we're looking for. Does he reach the building or not? And so what we're going to end up doing is using that formula, negative b over 2a. So let's find it. X equals negative b, which is 200, over 2 times by negative 16. Now, instead of multiplying right away, watch what I'm going to end up doing here. Because I really want to just find the y value. So we're just going to reduce this fraction to make the problem easier. See how that makes 100, because I took out the common factor of 2. And I see 4 goes into these two numbers. So now I've got 25 over 4. And so the negative signs cancel. So that's my x value, which would end up equaling 6.25, whatever the time is. So minutes, hours, probably seconds. Anyhow, what we want to do now is find out what y is using this time. Now let's use this number right here. And this is why fractions are kind of handy to be able to deal with, because watch how fast the problem goes when we use these numbers. See, I'm going to square that number and then plus 200 times that 25/4. And it helps out in this case because the problem ends up working out really nice. See, the 4 goes into this 200 50 times. You multiply these two numbers here, we end up with a 5 times 25 is 125 and add a 0. All right, that's plus sign. Now this, we've got to square this number first, which makes 625 all over 16. And then we got to multiply by negative 16. But look what happens to those 16s. They cancel out. And so now we just have that negative 625. So negative 625 plus 1250, and we do the subtraction, we end up with 625 again. So 625 feet. So that is higher than the 612. So he did end up clearing it. So 625 is greater than 612. So yes, he does end up making it. So those are the problems you'll end up seeing on tonight's homework. Good luck.